In this video, we're going to look at scientific notation. So scientific notation is something you're going to use in more of a science class type setting, but it deals with a lot of the exponent properties we talk about in math class. So scientific notation is a shorter way to write very large or very small numbers, and it's going to be written in this form right here, a times 10 to the n, where a is a number between 1 and 10, but it cannot be 10. If you notice, there's just the less than sign by 10. So 1 to 9.9999999, it's got to be a number with no tens digit. So let's look at how you do this. 3400, we can write in scientific notation. The way we do this is we say, well, where's the decimal place? And right now it's right here. And I need to move it over until we are at a number between 1 and 9.99999. So I'm going to move it over once. That's 340.0. I'm going to move it over twice. That's 34.00. That's not between 1 and 10. So if I move it over one more time, now we're at 3.400. So the way I would write this in scientific notation, I'm not going to use the blanks over there. I'll just do it in the blank space. It would be 3.4 times 10 to the what power? Well, if we did 3.4 times 10, that's 34. If we did 3.4 times 10 times 10, that'd be times 100, that'd be 340. So this is 3.4 times 310, so it'd be 3.4 times 10 to the third. And really the rule is however many times you move it over, 1, 2, 3, that's what your exponent's going to be in scientific notation. Okay, so 507,000. We start here, 1, 2, 3, 4, 5 spaces over. It'd be 5.07. We don't need to write the extra zeros on the end, but we do need the 07 times 10 to the fifth power because we moved it over 5. The next one, our decimals right here. I need to move it over. Now it's 0.089. Now it's 0.89. That's not between 1 and 10. Now it's 8.9. So this would be 8.9 times 10 to the, and not to the third, even though we moved it over 3 spots. This, what I have here would be 8,900. We moved it the other way, so this would be 10 to the negative third. If you have decimals, it's going to be 10 to the negative power. If you have numbers bigger than 10, it's going to be 10 to a positive power. So 0.205, we move it over once. It'd be 2.05 times 10 to the negative 1. Okay. What if we have numbers not in scientific notation, we want to go the other way? Well, 10 to the 7th is, well, let's kind of break it down a little bit here. 10 to the 2nd would be 100. 10 to the 3rd would be 1,000. So it's basically however many, if you have 10 tens multiplied together, sorry, 7 tens, there's 7 of them. This would be a 1 with 7 zeros. So it'd be 10 million. On this one, 10 to the negative 5, if we had 10 to the negative 1, that's going to be 1 over 10, and that's 0.1. So 10 to the negative 1, yeah. And so if we had 10 to the negative 2, that's 1 over 100. That's 0.01. So the thing I notice here is my exponent is negative 2, and I have 1 0 before the 1, or I have 2 decimal places. Here, if it's 10 to the negative 1, I don't have any zeros before the 1 and the decimal, or we're at 1 decimal place. So if it's 10 to the negative 5, this would be 0.00001. We'd have 4 zeros before the 1. Okay. 6.5 times 10 to the third. So I always think to myself, is this going to be bigger or less than 6.5? It's going to be bigger because we're multiplying by 10 3 times. So that means I'm going to move the decimal 1, 2, 3 times. That would be 6,500. If I have 4.9 times 10 to the negative 4, that's going to be smaller than 4.9, so I'm going to move it 1, 2, 3, 4 times. So there's my decimal now. I have 1, 2, 3 zeros in front of that, so it would be 0.00049. And so this, I kind of explained this already. We'll talk about it real quick. 65,000 is the same as 6,500 times 10. It's the same as 650 times 10 to the second. It's the same as 65 times 10 to the third. And it's the same as 6.5 times 10 to the fourth. So every time you move that decimal place over one, you're multiplying by 10 one more time. Okay. So what I'm getting at here is every time I move the decimal over this way, my exponent is going up by 1. So I move the decimal over to the left again, exponent on the 10 goes up by 1. Same kind of thing on this one. If I move the decimal over, my exponent goes down by 1. So this would be 10 to the negative 3. This would be 10 to the negative 4. So when we move the decimal to the left, then our exponent goes up by 1. If we move the decimal to the right, the exponent goes down by 1. Okay, so these are almost in scientific notation, but they're not. I need to get them in that scientific notation. So this I have to move 1 to the right. That would be 3.4 times 10 to the, so let's see, if I move to the right, my exponent goes down by 1. So this is going to be 10 to the negative 6. If I have 85 times 10 to the 7th, that's not in scientific notation because this is not between 1 and 9.99999. So I'm going to move this over. This would be 8.5 times 10 to the 8th because I moved it to the left. Okay, then the other thing that we're going to talk about is multiplying and dividing numbers in scientific notation. This is something that you'll see a lot in science class. So what we talk about in math is 2 times 10 to the third is really 2 times 10 times 10 times 10. And 3 times 10 to the fifth is 3 times 10 times 10 times 10 times 10 times 10. So that's if I expand it out. You definitely don't have to do this every time, but we'll talk about the shortcut in a moment. But we can multiply 2 times 3, that's 6. And then we have 3 tens and we have 5 tens. So this would be 6 times 10 to the 8th. Okay, so how do we do this then? What most math teachers will say is you're going to multiply the numbers out in front, 2 times 3, and you get 6. And then you're going to add the exponents on the tens, and you get 10 to the 8th. But I wanted to explain why that works, not just the rule. Okay, so let's kind of apply that rule here. If we multiply, I'll color coordinate this, here we go. If we multiply the 4 and the 1.1, I can do that one without a calculator, that's going to be 4.4. And then times 10 to the, what? So we have negative 4 and negative 6, kind of using what we learned up here, that would be 10 to the negative 10. And then on this one, same idea, we're going to multiply the 5 and the 3, that's 15. And then we add our exponents. 2 plus negative 7 is negative 5. So this is great, but it's not in scientific notation because 15 is not between 1 and 10. So I'm going to move that decimal place to the left, and we get 1.5 times 10 to the, so then what is the exponent? We moved it to the left, so let's go back up to our notes here. We increase it by 1. Well, negative 5 plus 1 would be negative 4. So that would be this in scientific notation. Dividing, similar idea. This would be 8 times 10 times 10 times 10 times 10 over 2 times 10 times 10 times 10. I know this seems a little bit silly, but I want to get the point across. We have 7 tens here. What we can do is we can cross out 4 tens on top and bottom, and we're left with 3 tens on the bottom. I can also reduce 8 over 2, and that becomes 4. So this would be 4 times, and what we would write, before is we'd say 4 divided by 10 to the third. But if we have 10 to the third on the bottom, that's not written in scientific notation, so we're going to say 4 times 10 to the negative third. We brought it up, and it makes it negative. So in this case, we are okay with negative exponents. So that would be our final answer in scientific notation. All right, so what's the general rule here? We take the 8 and the 2, and we simplify that, we divide it, we get 4, and then we take our exponents, the 4 and the 7, and we subtract them, and we get negative 3. That's kind of how you're going to attack most of these. So 3 divided by 4, that's a fraction I'm comfortable with. That is 0.75. And then I'm going to subtract these two exponents, and I get 10 to the 6th. Once again, this is not in scientific notation. I need to move that decimal point over. Now it's 7.5 times 10 to the, if I move it to the right, I go down by 1, so it'd be 10 to the 5th. And then the last one, this may seem a little bit undoable without a calculator, but I know that 32 divided by 8 is 4. So 3.2 divided by 8 is 0.4. You can always bust out a basic calculator for that though. Times 10 to the 6 divided, or 6 minus 1 is 5. I also need to move this decimal point over 1. So this becomes 4 times 10 to the, and if we move it to the right, we go down by 1, so it'd be 10 to the 4th. All right, so that's it. That's scientific notation in a nutshell. The main thing you need to get out of this is how to multiply and divide scientific notation.